Hi everybody who is watching this video. My name is Sir Olenjolai TAYAI from the beautiful, fantastic and unique country called the United Republic of Tanzania. I would like to welcome you into our official YouTube channel that's called the Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. Well, in this official YouTube channels that we are solving a particular problems that facing students and even some of the teachers who are in ordinary diploma level. Okay, so it happens that when I've been pursuing my undergraduate studies, and even yourself also, I've been in one of the institutions in United Republic of Tanzania where that it enroll many ordinary diploma students to pursue different courses in science and engineering, especially at lab science, for the biotechnology and some other scientific courses. So when I've been there, that I realized there is a common problem that facing them. They fail to understand engineering and scientific mathematics. And you know that they have to learn mathematics, engineering, also and scientific mathematics for all the 6 semesters, because usually the ordinary diploma is taken for engineering and scientific courses is just for 3 years. So many students they used to suffer. Even now they are still suffering, and even in near future they'll be suffering because of different reasons that encounter them to let them fail. And even many of the students, they used to have supplementary exams in mathematics. Okay, whether sometimes you find that the majority of the students they used to have supplementary exams in semester 1 and semester 2. So the great problem is there are many causes of this problem, but one of them is the mode of teachings and how the students have been encouraged that this knowledge that you are learning right now you need in your core modules. Okay, so there are many problems that I don't have enough times to mention all of them, but I've just touched one of them. On my side, I've decided to share or to use different techniques, different tips, different teaching aids on teaching ordinary diploma students worldwide, but specifically or with a main focus to Tanzania diploma students who are pursuing engineering and scientific courses, right? So I will be trying my level best to solve. I don't know everything about it, basic engineering and scientific mathematics for diploma students, but I just know the small portions, and I'm ready to share, and I'm ready to simplify, I'm ready to take complex issues and make them simple. You know, it happens that according to my research that engineering and basic engineering and scientific mathematics for diplomas is not complex. So you can learn it yourself, and even you can master, you can enjoy it, and you can make it simple as well as you can. So join me in this program, and I'll just ask you to do some few issues for you to get connected. We'll be uploading many videos on this our official YouTube channel. So make sure that you subscribe onto our YouTube channel. That below here, press that button. So you sign in with your email, because without an email you cannot subscribe. So subscribe in order for the YouTube community to give information once we upload a new video. Again, another thing is, please share these contents with some other students who are in this level, because the materials will be uploaded here will be focusing and training the students for the benefit of just for the focus of diploma or ordinary diploma in any engineering course or scientific course, telecommunication, mechanical, lab science, biotechnology, food science. See, so all of those courses that they need mathematics in order to understand different concepts. So make sure that you share. That's number 2. Number 3, make sure also that you read the descriptions of each video. And then number 4, which I insist you that my classes will be incomplete without questions from our students. So You are the students who is online students. This is the serious programs and serious channel. You can use the comment section to ask your questions and even to read answers from other students, and even also to establish the online group discussions. So you can use the comment sections. I'll try my level best to answer those questions, okay, as well as I can. Again, this is a serious program. Make sure that you are serious and make sure that you have all the resources, reference books, reference materials that required for you to learn this course. Right, so we are in departments of engineering and scientific mathematics. The modules of the course is called trigonometric and vector. As I told you that these modules might be called trigonometric, vector, and complex numbers. So don't worry about the name. Okay, the main focus is because different institutions or different colleges or different universities, they have different curriculums. So don't worry about that. Just look the contents. And because, for example, in the United Republic of Tanzania, that all the many of diploma programs for different institutions are under the institutions we call it, or under the authority we call it NACTE, right? So the topic for today, I'm going to teach you the second chapter that's called a vector, and then we'll start with quick review. And then the year of study for these programs is first year. It happens that in many institutions, for example, the Rest Minister of Technology, they used to learn this course in second semester of their first year. Okay, this is lecture 3. If this is your first video that you're watching right now, make sure that you go through lecture 1, lecture 2, lecture 1A and B, lecture 2A and B in these channels before you come onto this said lecture, which I'm going to teach you about laws of 40 of vectors. So I believe that you have too much information, but again, in case that you feel from your heart that you want to offer God your freewilling thanksgiving offering in order to participate or in order to contribute on running costs for this program, so you can use this telephone number at 0759745331 in order to send your thanksgiving offering, and your thanksgiving offering will be received with thanks, and even will be used effectively in order to spread the knowledge of basic engineering and scientific mathematics worldwide. So you're welcome. You are well invited to offer your thanksgiving offering. So don't hesitate yourself. But in case you want to do mobile transactions, go to the descriptions. Read the descriptions of each video. Then you'll see the account number and even the bank name. So now I believe that you are in right position, so we can start our session. So let us start with quick review of lecture 2. In lecture 2, basically I taught you about terminologies. First of all, I taught you about representation. Okay, representation of 40, presentation of a vector. It was a kind of long lecture, right? Presentation of vector. First of all, we say that we have dimension. I talked about 2 dimension of a vector, right? Of a vector, and then I told you that we have 2 dimensions. We have 2-dimensional vector, and also we have 3-dimensional vector, and a duty for you. Again, we say that we can present this geometrically. Okay, we can have geometrically, we can present them geometrically, and also you can present them in form of 40. So geometrically, can present them also in form of points, or in form of, yes, we call it just points, geometrically, and in forms of points. So that is, so you have 2 ways of presenting a vector by using the, yes, directional vector, that I, J, K. Okay. Again, I told you that some of the terminologies, I told you about position of vector, and I told you about what the meanings of displacement, this is number 7, what the meanings of magnitude of vector, what the meanings of eco-vector, what the meanings of opposite vectors, what the meanings of parallel vectors, right? Parallel vectors, and what the meanings of, yeah, so position displacement, as I say, parallel vector, magnitude, unity vector. Okay, so we learned a lot, so make sure that you go through them, and then we that we go through them so you can join me in continuations of this lecture. So today I would like to start where we ended in the second session or in lecture 2, where I just wrote a question, I didn't solve it, and then we'll go further to the step. But I just wrote example 4. Actually it was the homework, but you can even still try that. You can pause the video and try yourself before you do the correction. So this is kind of the quiz, but it was a homework for the lecture 2. So find the magnitude. So the question states that find the magnitude and unity vector. Find the magnitude and unity vector. Find the magnitude and unity vector of a vector. Vector 2i minus 3j plus k. So this was the question that I left it for you. So you can pause the video, you can try your level best, and then you can come for the correction. So let us just redeem the time, because today I want to teach you the 8 terminology, and then we got the laws of vectors, which are very interesting part, because we'll be just speaking geometrically. Find the magnitude and unity vector of the vector, this one. So first of all, we can name this vector that suppose that we can name that the vector A is equal to 2i minus 3j and then plus k, right? So this is 3-dimensional vector. It has 3 directional vectors, I, j, and k, right? So if that's the case, we need to find the magnitude. So to find the magnitude, first of all, magnitude vector A, we say that this is the square root. For this case, it is x components plus y components square plus z components square. So if this is the case, so you have what is 2 square plus negative 3 square, then plus 1 square, right? So then we say that the magnitude of vector A, this is equal to the square root. 2 square, it is 4, plus 3 square, it is 9, then 1 square, it is 1. So the response is equal to what? Is equal to 14. So square root of 40 or 14. That's the magnitude. So therefore, we say that the magnitude of a vector, of a given vector, is what is square root of 40 of 14. Okay? So to find a unity vector, also we say that the second step we said that recall what I told you, that we call the unity vector, the formula for the unity vector of maybe of vector u. So that's this one. This is given as a vector u of a magnitude of vector u. So for this case, so this the symbol for the unity vector, we have let our vector to be A, so the unity vector A is equal to vector A itself over magnitude of vector A. So what is vector A? So what are the components of vector A? 2i minus 3j plus k, and hence divided by magnitude of vector A, which is square root of 40 or 14. So therefore, we say that the unity vector of what? Of vector 2i minus 3k, minus 3j plus k. This is given as what? 1 over square root of 14, right? 1 over square root of 14, and then say 2i minus 3j, then plus k. So you can have the wave lines. So this is a response of the question. Okay, so that is how we deal with magnitude of a vector and unity vector. So in case that you want to learn through too much details, make sure that you got the lecture 2 when I taught these 2 concepts in detail, right? So that is the 7th terminology. The 8th terminology, before I teach you about the laws of vectors, The eighth terminology we call it direction of a vector. Say direction of a vector. Okay, direction of a vector. Direction of vector, right? So direction of a vector is very important terminology, because we have two-dimensional vector and the three-dimensional vector. So we say that in a direction, we say a vector has both magnitude and dotting and direction. So we say the direction of a vector, direction of a vector is given by the angle, say angle of a vector. So we have two-dimensional vector and we have three-dimensional vector. So to determine the angle or the directions of two-dimensional vector is very simple, because we just need to use the trigonometrical, to apply the concept of trigonometry in vector concept. But for three-dimensional, it's a little bit challenging. We have a concept, we call it directional vectors, which is beyond of this level of ordinary diploma or basic mathematics diploma. But I used to teach the concepts of directional vector in A level. So in case that you want to learn how to find directions of three-dimensional vector, make sure that you go to our official YouTube channel that called Tanzania Online A-level secondary schools in square bracket Olenjolai M. So then you learn how to find the directional vector of three-dimensional, because it's beyond of the curriculums of this level, at this level. However, that's not difficult, it's simple. You can know as a mathematician. Okay, so we say that if example that we say that consider a vector A, okay, consider vector A, which is given as what? As x I plus what? Let's say plus y j. Okay, so we have a plane like this one. Consider that we have a positional vector, right? So that the positional vector, this is origin, for instance. Suppose that this is x and suppose that this is y. Okay, so it means that we have a point where these horizontal lines and vertical lines meet. So this is the point. So here we have a positional vector, and this is origin, and this is supposed that it's a certain point, that let's say point A, right? So here we have vector OA, and here we have an angle which ought made between the vector OA, positional vector OA, and OT and X axis. So this angle is very important. So now if we just prolong, so we have dotted lines like this. So we say that this vertical components will represent y, and this horizontal components will represent the x, right? So this is the dotted lines, and this is the x. Let's say that this is x1 and this is y1. So this is y1, this is x1, right? So fine. So in case of vector, so we say that this is y1, the magnitude from this point to this point is y1, and the magnitude from origin to this point is x1, right? Great. So this is the angle that we want to find. So if that's the case that we say from trigonometrical concepts, we say that tangent of angle theta, this is given by opposite of the angle, right? Of what? Adjacent side. Opposite side of the triangle, right angle triangle, because this is right angle triangle. Opposite of the right angle triangle, so OAB, right? So opposite side of right angle triangle of adjacent side of right angle triangle. So for this case now we say that tangent of angle theta for this case is equal to y1 over x1, right? So good. So we say that this is tangent of angle theta, is equal to y1 over x1. So angle theta, this is equal to arc or tan inverse. If you divide by tan both sides, y1 over x1. So we say that generally, the angle, so generally the angle of two-dimensional vector is given as this. This is direction which you call the angle. So direction, this is given by arctan or tan inverse of y component over x component. So this is very important formula for the lovers of mathematics, like that. Or in some of the books, or sometimes we say that this is arc of tan theta, so tan what? Tangent of y components over x component. So also this is direction of the vector. Okay, so it's simple. So for example, that we can have example 5, right? Example 5. So example 5, we can say that find a direction. Find the direction of two vectors. So to find the directions of one vector, and hence it can give a home. You have to be careful about the issue of quadrant. Okay, so example 5, we say that find a direction of A vector B is equal to negative 2i plus 2j. Then we have from B, we have vector A. This is equal to 6i plus 4j. So this I will leave it as a homework for you. You can do for the first part, that Roman A. So solution. So we say that the question find the directions of vector B. So we say that the first step we say that compare, or we say that yes, compare vector B with the general vector. So it is this one to J, right? So it means that if you compare with general vector, this is xi plus yj, or this is negative xi. So it means that the x component for this case is negative 2, and the y component is positive 2. So we go for the second step to find the direction. We just deal with an angle. So to find direction, we say that theta, this is equal to tan inverse of what? Y over x. So we say that theta for this case is tan inverse of y. What is y? Y it is 2. What is x? It is negative 2. So simply this is equal to tan inverse of what? 2 over 2, it is negative 1, right? So negative 1. So if you find the angle by using your scientific calculator, the tan inverse of negative 1, it is negative 45 degrees. But remember that in mathematics and even in engineering or in science, we are interested on rotating the geometry or the XY plane in anti-clockwise direction, so in positive direction. So it means, for example, if we sketch that, we sketch this vector, that will be the 30. Okay, we can just say that it's not meaningful to leave the angle in negative degree. So the steady state vector, we say that state, okay, state vector B, right? State vector B. This happens in case that you have negative x components or negative y component. So sketch vector B. So if you sketch the vector B, right, roughly, right, so this is y component, y axis, and this is x axis. So this is origin, right? So we have, this is 2, right? That is 2 positive, and this is negative 2. And then here you have positive 2. So it means that our vector will be a positional vector from O. So this is our positional vector, and this is positional vector. So here we have negative 2, 2, and this is positional vector B, right? So listen, so the angle, the actual angle, if we rotate, because this is 0 degree in trigonometrical, this is 90 degree, this is 180 degree, and this is 270 degree, and this is 360 degree, right? So actually, if you rotate in anti-clockwise direction, so let me just sketch this angle properly. If you rotate this angle, we check the angle that made by vector B, then we find that the angle of negative 45 is the true angle, but right? So where do we find this negative 45? So negative 45 degree in mathematics, we mean that we rotate the angle in a clockwise direction, because the actual angle for this one is this one. This is the actual angle. This is angle theta. That's the angle made by vector B with respect to x axis, right? So it's from this point up this point. But now, so this is in case we rotate anti-clockwise. So remember that this is anti-clockwise. Just to remind you, anti-clockwise. And vice versa, it is clockwise. So where do we get 45? 45, it has been obtained as the rotation from what? The rotation from 180 degree in clockwise direction. So this is what we call the negative 45 degree, right? But negative 45 degree, it has been rotated from 180 degree to this point, while the actual angle should be rotated from here to here. So what do we do in 3D? Because that is kinds of a straight line, and the total angle for the straight line, according to what we have taught you in Form 1, is 180. So basically we can say that the direction or the actual angle now, so the angle theta for that case will be 180 plus, let's say theta, let's say this is theta 1. So yes, so suppose that this is theta 2 or theta 1 is equal to that one. So this is not a general solution, so don't confuse these concepts of general solution. So in this case, what is theta? So theta is negative 45 degrees. So it means that theta 1, this is equal to 135 degrees. Also, or in 3D also, we can say that you can find theta 1 by taking 360 and then we plus with angle that we found, which is negative, right? So what does it mean? It means that another corresponding angle, we can say that we can find that, suppose that this is the image of this line, right? So this is the image of this line. So it means that we say that suppose that also we can obtain this angle of negative 45 if you rotate, because that is tan. So tan is negative in the second quadrant and the fourth quadrant. So even this one is negative 45 degree, right? So it means that theta 1 also, this is equal to 360 plus negative 45, and the response is equal to 315 degree. So therefore we say that the direction of what? Of vector B is what? Is either 135 degree or 315 degree. So that's the response. And then you are done. So you see, it's simple to find directions of what? Of two-dimensional. So as I told you that directions of the three-dimensionals is beyond of this syllabus of basic engineering and scientific. But in case that you're interested in, you can go to A level or to the course, to another course that we call the Advanced Pure Mathematics, okay, for Form 6, which is the second chapter that we call the vector, and I used to teach how to find directional vector of three-dimensional. Okay, in case that you have any questions concerning about terminologies, right, of vector, because vector is beautiful, fundamental topic for all the courses of science and engineering. So don't hesitate yourself to ask in the comment section. I'll try my level best to answer your questions, and I'll be happy, right? So if that's the case now, I think that you are ready. Let me take you to the next step of laws of vectors. How do we add vectors geometrically? How do we add a vector and another vector? How do we subtract them, right? So how do we combine more than one vectors, right? Because we need them sometimes in case of survey or in case of flight. Maybe we want to fly, maybe an aircraft is flying from Kia, Kilimanjaro International Airport, maybe to Amsterdam, right? And then after Amsterdam, then we'll go to the New York. So there we have to draw a trajectory. So that is a vector, a vectorious, and sometimes that we need to know the hypotenuse, or the shortest distance, the longest distance and the shortest distance. So it's very important for you to budget it. Okay? So now we go for the laws of laws. So say laws of what? Of vectors. There are some laws, especially 3 laws, that govern the operations, the basic operations of vectors, geometrical, especially geometrical, right? Geometrically. Okay? So laws of vectors. So we have 3 laws. So we say that there are three basically laws of what? Of vectors. Of vectors. Okay? These are the first one, we call the triangle law. Say triangle law. And the second one is called parallelogram law. Parallelogram law. Right? And the third one we call the polygon law. Say polygons. Polygon law. So let us learn each of the law, and then we see that how we apply it. So let us start with triangle law. So say triangle law. So triangle law is similar to the law that we learn in physics when we learn about scalar and the vector quantities. So the fundamental question we say that let us state, we are the scientific and engineering students, let us take the triangle law. How do we state it? Right? It's not commonly asked in exams, but you know, it's better if you know something. Okay? How do we think about it? So you say, if a body, so let's read carefully this law, and so we present it geometrically, is acted upon by 2 vectors. If a body is acted upon by 2 vectors, right? By 2 vectors, represented by 2 sides. Presented by 2 sides. Presented by 2 sides of a triangle. Of a triangle. Of a triangle. taken in order, for triangle taken in order, the resultant vector taken in order, and we say that the resultant vector, say resultant vector. So the resultant vector, this is taken. The resultant vector is represented by the third side. Is represented by the third side. Is represented by the third side of the triangle, by the third side of the triangle. So this is how does it stay. So let me discuss. If a body is acted upon by the two vectors represented by the two sides of the triangle taken in order, the resultant vector is represented by the third side of the triangle. Listen carefully. I told you that a vector always should have an initial point, and a vector also should have a final point, right? So suppose that we say that we have, let me present geometrically, geometrically, say that the triangle law will be presented like this. Okay, the triangle law will be presented like this. Okay, suppose that we have a vector. Yes, we can say that, suppose that this is initial point. So this is vector A, right? So this is initial point. or 40 of a certain vector, vector O, and hence this is the ending point is vector B, right, for the first vector. And then we have another vector. So we say that if if a triangle, if a body is acted upon by the two vectors, right? So upon by the two vectors, so we have against another vector here, right? So we have another vector here. Suppose that this is vector C, right? So this is vector C, or it ends at a certain point, which is vector C. Suppose that this is vector A, or you can write just like yes, you can write that this is vector AB, and we can even let it is equal to vector A, let's say, fine. And also this one we can write as vector AC. So these are the two sides of 40 of a vector, and here we have a certain angle, right? These are the two sides of the vectors. So according to the law, we say that, or state that this is C. So here the said part will be a resultant vector. So the said part will be resultant vector. So this is the said part, right? So you have point AC. So you see. So we say that we have a vector. So for this case, we have that a vector that, let's say, from point A to C and then point D. So listen carefully. So suppose that a body is acted by the two vectors, vector AC and vector CB. So the third part, or the third side, or the resultant will be vector AB, because this is initial point and this is final point. Right? So initial point, point A, final point, point B. So you have vector AB, and you have vector AC, and you have vector CB. So if that the case that according to the triangle right now, we say that vector AB is equal to vector AC plus vector CB. So is this triangle law? So this triangle law is a resultant vector, which is vector AB, is equal to vector AC plus vector CB. Right? Similarly, we say that vector AC, this is equal to vector AB minus vector CB. Also, we can make vector CB the subject. This is equal to vector AB minus vector AC. So this is still triangle law expressions. So we use the triangle, it means that we have deduced the formula from the triangle. Okay? When we have the initial point of the vector, the initial point of vector AC is A, and the initial point of vector AB is A, but the final point is B. Right? So this is not the final point of vector AC, it's just like the continuation. So that is all about triangle law. Is it interesting for you? Yeah. So after teaching you the triangle law, the next law is called the parallelogram law. Parallelogram law. Parallelogram law. How does it state? So the question is, state the parallelogram law. So we say that, how does it state? Quote the reference books. It's a little bit long. It's a little bit long, but be patient on this. We say that it states that the resultant of two vector quantities. Two vectors quantities presented in magnitude direction and the parallelogram. And parallelogram, both of which are directed toward or away from the point of intersection. Is a diagonal of the parallelogram. Through that point. Through that point. So the statement said the resultant of the two vectors, quantities represented in magnitude, and just don't underline, I'm just underlining the keywords, magnitude, directions, and parallelogram, both of which are directed toward or away from the point of intersection, is the diagonal of the parallelogram through that point. What does it mean? Suppose that we have two vectors like this. Suppose that we have a vector, certain vector, this, and then CF against another vector. Of this size. See? So it is a resultant of the two vectors, quantities presented in magnitude, direction, and parallelogram, both of which are directed toward or away from one point. So this is the one point. So suppose that this is initial point, which is point A, right? And then you have a certain vector. This is heading to point B, and this is heading to point C, right? You see? So with these three lines, we can establish other two parallel lines. Okay? Possibly I might not be correct in angles, but I'll try my level best to Okay, so that the parallel line. So I think that this is still so we can have this size of value. Okay, and then here we say that this is so you can find that so this is the longest yeah. So this is 15 and here it is 15. So I try my level best pattern for you, can stretch it. So remember that we had only two vectors. So we had only two vectors. Had only two vectors. Had only two vectors. Had only two vectors. Right? So A, B, C, D. So you can find that this is a parallel side and this is another parallel side. Right? So according to this law, the result of the two vectors, so vector AB, so here we have vector AB, and also we have vector AC. So the resultant of the two vectors, AB and AC, quantities represented as magnitude, directions, and parallelograms, both of which are directed towards or away from the point of intersection. So these two vectors are directed away from point of intersection, which is A, okay, and then D, okay, away from the point of intersections is the diagonal of the parallelogram through the point. So in this parallelogram, we have two diagonals. The first diagonal is this one, which will be the resultant vector. So this is a diagonal, same diagonal. So this is diagonal of this vector. So this is diagonal, which is the resultant. So you can have that, suppose these sides are parallel like this, and even this one also is a diagonal. So you say that this is diagonal. This is diagonal side, which is the resultant. So in maths, we say that initial points, that is a diagonals, the resultant of the vector C. So in this case, we can find that, okay, so remember that this vector AB is parallel to vector CD. So we can say that this is vector AB and vector AC is parallel to vector BD. So this is vector AC. So they are parallel and they are equal also vectors. So it means that if you have this one, so you can find that this is still resultant. So from the initial point. So this is initial point if you consider triangle. So if we consider a triangle A, C, D, right? So if you consider triangle A, C, D, so these are the two vectors and this is the resultant, right? So you can find that the vector AD, which is diagonal, right? This is equal to what? This is equal to vector AC, which is the adjacent side, plus vector AB, which is the parallel side. That is. So that is parallelogram law. So this is the diagonal, and this is size of the parallelogram, right? So similarly, we can make vector AC the subject in case that we find the way problems are demanding us about that. this will be AD minus vector AB. Or can also make vector AB the subject by taking vector AD minus vector what? AC. So those are the formulas for pyrogram laws. You will find that later on we can recall these laws on doing manipulations for vector quantities, right? So make sure that you go through it. That's all about 30 pyrogram law. We'll see how we can apply it, yes, that is necessary. Another law, which the last one, is polygon law. So this pyrogram law and the triangle laws, they are dealing with just the additions or resultants. The idea means to find the resultants of the two vectors. Polygon's law now, this is kind of advanced law because it can deal with more than two vectors. So number 3, here we have a law called the Polygon's law. Polygon law. Tell your neighbor polygon law, right? So how does it state this polygon law? Okay, vectors are joined together and a certain vector is obtained by completing the diagonal. So we say that polygon law says that vectors are joined together. More than one vector are joined together, right? Are joined together by what? Joined together, and the resultant vector is the vector that is closing the polygon. That is closing the polygon, right? That is closing the polygon. Okay. So if that's the case, we say that we have geometrically. So geometrically, let me have enough space. Geometrically, we say that in Polygon's law, we have more than two vectors. And remember that this lecture 3 of vector can be broken into lecture 3A and lecture 3B. Make sure that you learn through most of these lectures. So say geometrically, for instance, that we have some vectors like this. You have a certain vector here, and then you have against another, or you have a second vector, and then it's possible that you have another vector, and then it's possible you have another vector here. So suppose that this is vector A, B, C, D, E, right? So suppose this is initial vector, right? So initial vector, so this is vector AB. And then this is the next vector, this is vector CB. And then this is another vector, this is vector DC. And then this is another vector, which is vector DE. Okay? So we say that the resultant vector now is this vector. This is the closing vector. Right? That's a closing vector. So this is a closing vector, which we call TAE. So how many vectors are there? 1, 2, 3, 4, 5. So this is the initial point. Regardless that you have 10 vectors, initial point should be there, common initial point, and mostly the common final point. Common final point, because remember that the endpoint of vector AB is the initial point of vector CB. The endpoints of vector CB is the initial points of vector DC. The endpoints of vector DC is the initial points of vector DE. So this is the resultant. So we say that vector AE, for this case, vector AE, this is, we call the resultant vector, is resultant. This is resultant vector. It's a resultant vector. So because it's resultant vector, we can say that according to polygon law, we say that vector AE, this is equal to vector AB plus vector CB plus vector DC plus vector DE, etc., etc. So that's all about the polygons law. Say polygons law. That's all about polygons law. If you have any question about laws of vectors, don't hesitate to ask your questions in the comment section of this video, right? So that's all about the laws of vectors. Okay, laws of vectors. So with these geometrical representations of laws of vectors can help us to do some basic operations of vectors. So let me end with that concept and then we call we say that if a vector is represented as this A, B, C. This we call it in mathematics column vector. Column vector of 3 components. And also if it is be represented as A, B, C, this in mathematics we call it row vector. So if you have a row vector and a column vector, then you form something we call it mathematics matrix vector or matrix, right? So we call it a matrix. Row, there's a close relation between vector and the matrix. Okay, fine. So if that's the case, we say that, okay, good. So we say that we can do basic operation, additions and subtractions, which is basic operations. Basic operations of photo vectors, that will be the last point for this lecture. Basic operation. Basic operations of what? Of a vector. Basic operations of what? Of vectors. So we say that the vectors two vectors, two or more than two vectors, more than two vectors, more than two vectors, two or more than two vectors can be added or subtracted. Right? Subtracted be added or subtracted to form a single vector. So how? So for instance, that you have vector A, which is x1 I plus y1 j. Also we have vector B, which is x2 I plus y2 j. So if you want to find vector A plus or minus vector B, this in maths we say that we just take component x1 plus or minus x2 I plus what? Y1 plus or minus y2 j. So that's a general form. So it's simple like that. We can multiply also a vector with another vector. That's what we call T-dot product or cross product, which I'll teach you later in next lectures. But here we are dealing with, we can have also scalar multiplications, which I'll teach you in the next lecture. So you can have here example 6. Okay, example 6. This is take that. We have been given two vectors. Vector A, which is 2, 4, -5, and vector B, which is 2, 8, 2. Find A, vector A plus B. Find C, vector A minus B. Find C, vector B minus A. So this is homework. And also this is homework. Solution. Let me just solve part A, and this will be the end of the sessions, then we'll meet in the next sessions. So part A, it is what? A plus B. So this is column vector A, column vector B, right? So Roman A, we say that we are looking A plus B, so you just have to add the components. So this is 2, this is 4, this is -4, plus, then you have what? 2, 8, 2, right? So this will make what? 2 plus 2, it is 4. 4 plus 8, this is 12. -4 plus 2 is -2. So that is, so I say A plus B, this is equal to 4, 12, -2. That's the response. So this is the end of lecture 3 of laws of vectors or vector. I thank God who have been with me in preparations of this session, and also thank you for taking your time and joining me in this session. Make sure that you go through the question through the entire lecture from just lecture 3A and lecture 3B, and also make sure that you understand everything. In case you have any questions, please don't hesitate yourself to ask in the comment section. I would like to invite you again in the lecture 4, when that I'll be teaching about scalar and ratio theorems a little bit, and then we'll go to the dot product, which is a very interesting part of this topic. So I also insist you to go through some other videos and some other courses online, which can help you to master your study. So thank you very much. This is Olenjolai. May God bless you. See you in the next lecture. I love you so much.